My dear students, I am Ramesh, chemistry faculty from Vidya Mandir Metric Higher Secondary School, Uddangarai. And let us discuss nomenclature of coordination compound in 12th standard. Now, given to the salt of coordination compound. Suppose here PT, NH3, 4 times, PT, Cl4, and it is considered as manganese salt. Manganese salt. Manganese salt. And we may take the next one, that is K, PT, Cl twice C2H4. It is considered as Zysine salt. Zysine salt. So here, after numerous compounds are discovered, so that we may take here IUPAC nomenclature. What is that IUPAC? International Union of Pure and Applied Chemistry is nothing but IUPAC. And they will give this set of rules. So the first rule is cation first. Cation first and anion next. Anion next. So listen, while naming whatever the complex, cation first and anion next. Suppose we may take here K4, Fe, Cn6, and which one is cation? Now we may split it here, that is 4K plus, and here Fe, Cn6, 4 minus. Now it is a cation and it is anionic complex. Anionic complex. So here first we want to name it cation. So cation first and anion next. Cation first and anion next. Suppose in a normal ionic compound we are taking sodium chloride. Now what is the name? It is sodium and chloride. So we may name it first cation, sodium, and after that anion, that is chloride. So it is a sodium chloride. Likewise, in complex compound also, cation first and anion next. So here we want to name first cation. Then if there is a cationic complex, suppose we are taking the second example, that is Cu NH3 4 times NH3 4 times SO4. Now here if you are splitting, first we are getting the cationic complex. So what is it? Cu NH3 4 times 2 plus and SO4 2 minus. Okay. Now here it is a cationic complex. So the complex is cation. And after that it is a simple anion. So we are getting a simple anion. Now how will you name it? So the first one, it is a cation, and after that anion. If the third one we are taking here, both are complexes. Both cation and anion are complexes. Suppose that is CO En thrice and COCl 6 times. Now here it is cation and that anion. So first we may name it, that is a cation, that is CO En thrice 3 plus and COEN 6 times. Sorry, it is COCl 6 times and it is 3 minus. So first name it, it is a cation, after that anion. So here whatever the complex, cation first and anion next. It is the first rule. Now we are taking any complexes. So the second rule, we are taking any complexes. Suppose here K4 and FeCN 6 times. So first we may name it cation, after that anion. Now what are the species present in that coordination compound? Now here the 6. What is that 6? It is nothing but coordination number. Coordination number. So it is coordination number. Now what is a CN? CN is nothing but ligand. So it is ligand. Then what is that Fe? Fe is nothing but central metal atom. So it is central metal atom. So a complex is made up of coordination number and ligand and central metal atom. So in a complex, the next rule we are going to in a complex. So in a complex, which one is first? So the first one, it is coordination number. So first we will name it coordination number, and after that ligand, and after that central metal atom. And one more, if you are taking that, here it is 4K plus and FeCN6 4 minus. Now consider the charge of a complex. It is a charge of a complex. Depending upon the charge, we may name that central metal atom. So central metal atom is depending upon that charge of a complex. Charge of complex. So if you are consider the naming the central metal atom, then we may consider the charge of a complex. Okay. Now the first one in a complex, we may name it coordination number first. So naming of coordination number. Coordination number. Okay. Now how to name the coordination number? And the coordination number is 1, it is unique. Then coordination number 2. So if it is 2, we are taking that is a di. And 3, then it is tri. 4, then it is tetra. Then 5, then it is hexa. Then 6, then it is hepta. Likewise, we may name the coordination number. Now, a ligand is itself containing monoditride. A ligand is itself containing monoditride. Then, how will you name that coordination number? Suppose we are taken, that is En. What is that En? Ethylene diamine. So, it is ethylene diamine. And here it is considered as a ligand. And in a ligand, a di is present. So that this type of complexes, we may name it, if it is 2, then it is bis. 3, then it is tris. 4, then it is tetrakis. Tetrakis. So, a ligand itself containing monoditride, then the coordination number is said to be bis if it is 2 and tris if it is 3, then tetrakis if it is 4. Suppose that is En thrice. What is that En thrice? It is tris ethylene diamine. Likewise, if it is En twice, then it is bis ethylene diamine. And En 4 times, then it is tetrakis ethylene diamine. Likewise, we may name it. Okay. The next one, after coordination number, suppose we are taking a complex, that is Fe Cn 6 times 4 minus. So first we may name that this coordination number. It is the first one. Now after it is ligand. So the second one, it is ligand. So we may take a ligand. So naming of ligand. Naming of ligands. For naming, we may classify the ligand into 3 types. What are the types? One is here positive ligand and negative ligand and neutral molecule. So first one, we may take that the negative ligand. Negative ligand. So we may take that the negative ligand. And you know that the negative ligand, for naming, negative ligand is ending with O. Negative ligand is ending with O. For example, we may take here, that is F minus fluoro, or otherwise it is fluorido. So here generally in modern coordination complexes, we are taking that IDO, fluorido. Bromo or bromine, we are taking bromido. So here Br minus, then it is known as bromido. So in your book they are giving that is O. So it is not a fluoro, it is fluorido. Actually it is IDO. Then F minus and I minus. I minus, it is iodido. So IDO will be added. And if you take, that is Cn minus. Cn minus. And Cn minus, which is called as cyanido. So it is cyanido. So it is a cyanido. And NO3 minus. NO3 minus is a negative ligand and it is called as nitrato. Nitrato. So here it is not IDO, it is only with O. So that in your book it is given as O. And if you are taking SO4 2 minus, then SO4 2 minus we may consider it is sulfato. What is that? Sulfato. Then we are take, that is the antidentate ligand NO2 minus. And in NO2 there are 2 types, that is ONO minus and that NO2 minus. And it is known as ampidentate ligand. Ampidentate ligand. And in the case of ampidentate ligand, we using the term that is K. So if we are taking NO2 minus, then it is nitrito, then it is Kn. Why we are doing like this? Because here the donor atom is nitrogen. So the nitrogen atom is make a coordination bond with the central metal atom in a coordination complex. So that we are taking that nitrito Kn. Now, if you are taking ONO minus, and if it is ONO minus, here also it is nitrito and KO. And what is the meaning of it? Here, oxygen making a bond to central metal atom. So that we may take for an ampidendate ligand, we may take that Kn or Ko, or we may use the term that is K. K is utilized. Then we are taking the same one, that is SCN minus and NCS minus. And here, what is that? Which one make a coordination bond with the central metal atom? And here it is a sulfur. So here Ks and here it is nitrogen. So that it is Cyanide and K and S. What is the meaning of Ks? S is making a coordination bond with the central metal atom. And here, which one makes a coordination bond with the central metal atom? And here nitrogen. So that it is isothiocyanate. So here isothiocyanate. Then it is the term K and here it is nitrogen. Likewise, we may name it. And if a compound contains more than one ligand, so we may take that the complex contain more than one ligand. Then we may name it in a alphabetical order. Suppose here that is a CO, NH3 twice and that Cl2. Then it is minus. So here there are two types of ligand. Then it is heteroleptic complexes. And any heteroleptic complexes, and it is naming as amine. And here we may name it into chloro. Which one come first? It is amine first and after that chlorine. So for we are taking the positive ligand. And a positive ligand is ending with IUM. A positive ligand is ending with IUM. Then if you are taken, that is NH3 plus and that NH2, then it is a positive ligand. And ligands are donor atom and it is electron donor. How it may act as a ligand? And here it has the lone pair, so donation of lone pair, it will be act as a ligand. Now the charge of ligand is positive, so that here hydrazine, what is that hydrazine? NH2 bond NH2 is known as hydrazine. Now if it is a positive charge, it is ending with IUM, so that it is hydrazinium. So hydrazonium is the name, so it is ending with IUM. Okay, then if we are taken NO plus is considered as nitrosonium, so it is nitrosonium. So if it is a positive ligand, it is ending with IUM. Now we may consider the neutral ligand. And neutral ligand we are taking as it is the molecular name. We take that the exception. Generally it is considered as ammonia. But in the neutral ligand, NH3 is considered as amine. What is that? Double M-I-N-E. It is not ammonia, it is amine. Then here these are all exceptions. And if you are taking that H2O is considered as a water, as a normal. But here the neutral ligand H2O is considered as aqua. What is that? Aqua. The same way here NO, which is considered as nitrosyl, and CO CO is carbon monoxide and here it is carbonide. Okay, so these are the exception and remaining all the neutral ligand is acetes. Suppose if you are taking the pyridine, acetes pyridine. So we are taking the ligand. There are three types of ligand. One is negative ligand and positive ligand and that neutral ligand. And the negative ligand is ending with O and positive ligand is ending with IUM. And neutral ligand, some exceptions are there. Acetate the molecular name and the exceptions are NH3 is amine, H2O is aqua, NO is nitrosyl and CO is carbonide. Okay, listen. The next one we are take the naming of central metal atom. So here naming of central metal atom. Central metal atom. Okay. Here we may take the same one. There are two types of complexes. One is anionic complexes and cationic complexes. So complex is split into two types. One is anionic complex and cationic complex, and it is depending upon the charge of a complex. So the charge is positive, then it is cationic complex, and the complex charge is negative, then it is anionic complex. For example, we are taking that is FeCN6 4 minus, and here that is Cu NH3 4 times 2 plus. Now it is the cationic complex and here it is the anionic complex because of a charge of a complex. Now listen, if you are taken the charge of a complex is positive, that is cationic complex. If it is a cationic complex, we may take the central metal atom is acetes the element name. Acetes the element name. So listen, here we may take that here copper, and actually it is taken as copper alone. If it is a cationic complex, then we are taking that anionic complex. In the anionic complex, the central metal atom Fe is not called ion. Here we may take that ferrate. What is that? Ferrate. So we are ending with Ate. So if it is a anionic complexes, the central metal atom is ending with Ate. So while naming of central metal atom and in a anionic complex, central metal atom is taken as it's a Greek or Latin word and it is the name is added with Ate, and if it is ion then it is ferrate. So if it is a ion then it is a ferrate. Then if you are taken that Sn tin, then it is stannate. Then if it is Pb, then we are taken that lead, then it is plumbate. So it is ending with Ate only for anionic complex. Now the complex may be a neutral. Suppose if you are taking that a neutral complex. In a neutral complex, we are taking that is here NiCO 4 times. Then there is no charge at all. Then it is known as neutral complex. Then how will you name that? Nickel. As it is nickel, not nickelate. Only an anionic complex, we are adding that ATE. So it is the central metal atom. Now we may take an example. So the first example we are take, that is K4 Fe Cn 6 times. K4 Fe Cn 6 times. Now what are the names? So first one we may split it. K4 Fe Cn 6 times. Now split the complex to identify the anionic complexes or cationic complexes. So what is it? It is 4K plus Fe Cn6 4 minus. Now the first rule, what is the first rule? Cation first and anion next. So we may take the first one cation, that is potassium. So we may take here K plus, we may take that it is potassium. And in a complex we may take FeCm6 4 minus. In a complex, which one is naming first? Then it is coordination number. Coordination number 6. So that we are taken as hexa. So here coordination number. Coordination number is 6. So that we are take hexa. Then after that we may take that ligand. And for a ligand naming, we may consider what is the type of the ligand. What is the type of the ligand? It is negative ligand. Negative ligand is ending with O. So that here the ligand is Cn minus. So we may name it, it is cyanido. It is cyanido. So hexacyanido. And after that we may naming that central metal atom. What is a central metal atom? Then Fe. And for naming a central metal atom, we may consider the charge. What is the charge? It is negative charge. What is the meaning of negative charge? Anionic complex. So if it is a anionic complex, the central metal atom is considered as a word, that is element name with ATE, so that it is ferrate. So the complex name, what is that? Here cation first, and after that anion next, anion next, and in that complexes we may take coordination number first, after that ligand, only one ligand, so that we may name it. If more than one ligand, then we may take in a alphabetical order, and after that central metal atom. Then we may consider the oxidation state of a central metal atom. So we are take oxidation state and find out the oxidation state. Here considered as X. So what is that? X and plus 6 into minus 1. Cn minus 1. So minus 1. And is equal to minus 4 charge of a complex. So X minus 6, which is equal to minus 4. Then X, which is equal to, what is that? Plus 2. And this plus 2 is written after the central metal atom in a Roman numerals. Roman numerals. So if it is 2, then the Roman numerals 2 in a parenthesis. So what is the complex name? It is potassium hexacyanido ferrate 2. So it is the name of a complex. So potassium hexacyanido ferrate 2. Okay. Now name these complexes. And here Cr NH3 4 times Cl2 and 6. Now there are two types of ligand, and we may split this one. What is that? Here CO NH3 4 times Cl2 and it is plus Cl minus and it is plus. So what is the types of a complex? It is cationic complex. So here it is cationic complex. So find out whether it is a cationic complex or anionic complex. Now we may take the oxidation number also. So here the oxidation state of central metal atom. Oxidation state of central metal atom, here it is X and ammonia is neutral ligand and here it is -2. So -2 which is equal to +1. So X which is equal to +3, so that we may take the Roman numerals 3. Now, so what is the first rule? Cation first. So what is the cation? Here CO NH3 4 times Cl2. It is cationic complex. Now we may get it is a cationic complex. So it is a complex, so that we may take that here first coordination number. And here the coordination number totally it is a 4, but it will be splitted into 4 for ammonia and 2 for chlorine. So that after that it is a heteroleptic complex. What is heteroleptic? Here two types of ligand. Which one comes first according to alphabet? Amine and after that chloro. So first we are taking the coordination number, so that here NH3 4 times, so that it is tetramine. So it is tetramine. Tetramine. Now here it is Cl2. So here di. So it is di2 and chlorido. So tetramine dichlorido. Now it is a central metal atom. So here central metal atom is CO. CO, it is a cationic complex. And while naming a cationic complex of central metal atom, as it is the element name, so that it is cobalt. Now oxidation state. Oxidation state, we are taking oxidation state, then it is 3. Correct? Now while naming these complexes, what is it? We are taking cationic first. So here tetramine, dichlorido, cobalt 3, and after that anion. Anion is chloride, so that it is chloride. So it is the name of the complex. And the next one we are taking, if both complex cation and complex anion. Suppose we are taking, that is CrEn thrice and CrF6. Now it contains both complex cation and complex anion. So here it is cationic complex, and here anionic complex. Now whatever it may be, first cation, after that anion. In a complex, first we may take that is coordination number. So here cation first. So naming, it is 3, and if it is 3 we are taking that tri. But the ligand is ethylene diamine. Ethylene diamine itself containing di, so that we may consider as tris. So here it is a tris. Then ethylene diamine and the UPS name tris diamino ethane. 1,2 diamino ethane is nothing but ethylene diamine. So ethylene diamine chromium. Ethylene diamine chromium 3, and here the oxidation state is 3 in both chromium. So here we may take this one tris ethylene diamine chromium 3, or here tris 1, 2 diaminoethane chromium 3. And after that, we may take this one. What is that? It is nothing for CrEn thrice. Now, we are taking CrF6. So, CrF6 and here 3. Then it is a negative complexes. Now, for naming here, that is 6. So that it is hexa. And it is fluorido. So, hexa, fluorido, chromate. Hexa, fluorido, chromate 3. Why we are taking the chromate? Because it is an anionic complex. So, whatever the complex, so first cation and after that anion. In a complex, first we may do that the coordination number. And coordination number is said to be monoditrile. A ligand itself containing monoditrile, then we are taking bis tris tetragase. And after that central metal atom. And central metal atom is named as a anionic complex, a element with that ATE, ferrum ferrate. And the neutral and that cationic complexes, the element acetes. Okay. So go through your textbook and do the examples. Thank you.